is I'm going to start off with a few challenges which I hope will kind of mean something to you. And these are things that are hard to do in Excel. Let me just zoom in a bit. Now what I've got here is I've got a list of some names. These are all passengers from the Titanic. And what I would like to do is split them up into, I've got the full name here. I'd like to split them up into the last name, the title, and the remainder. So for example, for our first one, the last name would be Braun, the title would be Mr, and the remainder would be Owen Harris. Now, of course, I can do this in Excel the old way. And what I want to notice is when I come on to my Excel spreadsheets, when I've got something in this kind of grey, that means the kind of old way of doing things. So the old way of doing things would be to, first of all, to use something like the find function to find out the position of the dot or the comma, which is the 6th character, and then use the left function to get us all the way to that 6th character. That would give the last name, find the position of the period after the end of the title, and then do some strange mid calculation to extract the string in the middle. So hopefully people I kind of relate to that and know that that's a kind of difficult problem in Excel. And what I've done is I've done it the kind of old-fashioned way. At the end of today, hopefully we've got a simpler way of doing that. And so we'll come on to that. Another issue that we might have in Excel is we might have several tables or several bits of data here. So here I've got some tables. They're just tiny tables, but imagine instead of 2 rows, they're 200 rows or 2,000 rows. And let's say I've got data for January, for February, and for March, and I want them all in one area, one table, where I've got the year to date. So how can I get those in without copy and pasting? How can I get those into this one table here? And also, subsequent problem, when I put in a new row here, how will so that this data here, that's the combined data, reflects that? So again, that's quite a hard problem to do. It has been a hard problem to do in Excel, but we'll look at a way to do that. The final third thing is let's have a look at a calculation. Let's say we want to do a calculation called the BMI. BMI, for example, simple calculation, body mass index. And a body mass index used in medicine quite a lot. You've probably been weighed by a doctor or nurse and taken your height. And what they do is come up with a number, which is your weight in kilograms, divide it by the square of your height in meters, and they come up with a number, and the number they categorize it into under 20 would be, let's call it underweight, 20, 25 normal, 25 and above overweight. But we've got a simple calculation here called BMI. And what we might want to do is have a table, a BMI table here, where we work out the BMI for a set of heights, people between 1.6 and 2 meters, and a set of weights. And of course, what we can do, if I click on this, is we can do it the old way. And the old way is using what we call mixed references. So we've got $6, $11. So we're fixing the row for the 6th row for the weight and the column. Is there an easier way? That's always a difficult formula. Getting those cell references right is always a difficult way. Is there an easier way of doing it? And you can probably see from the things down here that the answer to that is going to be yes, but we'll have a look at that. So hopefully 3 things that everybody, well, some of you can relate to some of them as problems that we've got. And these are problems that modern Excel solves. We'll come back to those in the end, at the end of it. So I'm going to just put that out of the way for the moment. And what I want to do is start with this Excel spreadsheet. Now, you can download this Excel spreadsheet if you want, and you can look at it later on. Let me just explain a bit about it. We've got a set of tabs, and like XLOOKUP, that's what we're going to starting off with. And we've got a corresponding green tab, XLOOKUP Final. And the Final tab is just a worked example of what it is. So if you want to look at the data later, and you can always look at how I've done it with the Final tab. As well as that, we've got some data, which I'll talk about later on. This is just a data set, a fictitious data set of 700 rows, represents kind of sales from a a kind of online store that has about 6 different products in a few different countries. And we'll be using it in our examples later on. I've also got some data of all the Star Wars characters and some kind of very personal information about them, their height, their mass, their skin color, their eye color, and their species. Again, we're going to be using that. Notice this is in a table, and this table is called, if I click on here, is called Star Wars up here, and we'll be using that. And the other one is a table, and the table is called Store, S-T-O-R-E, up here. So we'll be using those in the example to have introduced them. Now, I wanted to start off with this function XLOOKUP. It's an example of a modern function that I think really helps. And when I give courses on Excel, this is the kind of favorite section for lots of people. And it's because I think people hate VLOOKUP so much. Let's imagine that we have a very long list of fruits. And if people can mute themselves, that's really great, because I can't see to mute people. So if you can mute, that's lovely, unless you've got something to say. OK, so we've got a long list of fruits here from apple to peach. It's 4, but imagine it's 40 or 400. We know the price of them, clearly fictitious data, and we know how many quantity they've got in store, for example. So imagine this is a very large table. And what we typically want to do is do lookup here. What we want to do is we want to find out the price and the quantity of our peaches. Now we could do it the old VLOOKUP way, and what I will do is I'll just get rid of that for the moment and remind you, this is in the dark grey because this is the old way of doing it. So I say VLOOKUP, and I'm looking up my peaches, and I'm looking them up in the table of, this is a table that I've got. I'll fix that. And what I'm saying is the second column. So I put in column 2, that's the column of that table, the prices. And then I have to say false, because I have to say it's not, most times we want an exact match. We want peach, not perch or pouch or anything like that. So I can do that. And that's VLOOKUP. And then I obviously could copy it down. And so let's have a look at the XLOOKUP way. We're going to have a look at the XLOOKUP way in various situations. This is a kind of classic situation. And we'll see how XLOOKUP works, and then we'll see how it's more simple and flexible. So what I'll do here is I'll write XLOOKUP. So I'll start with XLOOKUP. And again, I'm going to look at my peaches. And this time, what I'm going to do, rather than ask for a table, I'm just going to give it the lookup array. The lookup array is my list of fruits, and I'll do that. And then it asks, what's the return array? This time, I'm going to give it the return array of prices. I'll click on that as well. And that's all I have to do. XLOOKUP is an exact match by default, because that's what we want 99% of the time. So I don't need to say anything else. I can just say that, and that gives me the XLOOKUP. And I can copy that down. Likewise for quantity, I'll just do it this XLOOKUP again. We're looking at my peaches, and we're looking up in the array this time, the array of fruit, and this time we just specify the array of quantities to come back. And we can copy that down. So XLOOKUP gives us the same as VLOOKUP. Now let's look at a couple of different situations. Here, for some reason, somebody's given us the data, but this time they've given us the data kind of horizontally rather than vertically. It happens. And for that particular case, we can't use a VLOOKUP. We have to use an HLOOKUP. But XLOOKUP can cope with it. So if I say XLOOKUP, again, I'm looking at the peaches. And what I can say this time, I can just give it a horizontal array of my fruits there, my apple, fruit, peach, and I can just give it a horizontal array of my prices. So XLOOKUP works for both cases, work for VLOOKUP and XLOOKUP. There we go, and I copy that down. I won't bother doing the quantity, but you get the point. Here's a situation where somebody's given us the data, and what they've given us the data in this particular case, they've given us the fruits. Our lookup array is to the right of our price array. And I'm not even going to try VLOOKUP because it can't work. VLOOKUP requires the lookup array to be in the first column. So it's just not going to work. But XLOOKUP is flexible in the sense that I can look up the peaches and I can choose my fruits array. There we go. And I can choose my price array. Doesn't matter where it is. I could choose it from there. I could even go and choose it from there. It doesn't really matter. But there you go. And so XLOOKUP works in the places that VLOOKUP just can't. Finally, I just want to show XLOOKUP working with tables. The difference here with this fourth one is that this data, actually I put it in a table. I talked all about tables in the last session, but what we've got is we've got a little Excel table here. The table is called, if I look at here up here, it's called fruit table, not the best name for it. And I've got three columns, fruit, price and quantity. So with XLOOKUP, what I can do is I can say equals XLOOKUP, again, my peaches. And what I'm going to do this time, I'm going to just click on, I can click on this and just say I want the fruit column of my fruit table as an array. And I'm going to return, in this case, the price table. Notice I haven't even need to think about fixing things. I've got a much nicer formula, a much more elegant and readable formula. So there we go. We can see the formula up there. I really like this. It tells us exactly what we want to do. And it's very nice. If I add, also if I add things here, if I have a strawberry, the first fruit that comes into the mind, and 50 and 10, say, if I want to add a strawberry here, this is where I can't spell. I should have chosen a fruit with a small and copy that down. That's all just going to work. Famous last words. There we go. It's all just going to work. So what I hope I've shown you is that there are these new formulas in Excel like XLOOKUP that are much more flexible and simpler to use than the older formulas. Likewise, there's formulas SUMIFs with an S that replace SUMIF. There's XMatch that replaces match. So a few kind of new versions of old formulas. Good. OK, we're now going to move on to functions that spill. And I'm going to start off with showing you the first function that spills. I'm going to use a unique function. We'll do it and then we'll see what happens. So I'm going to say, remember, I've got that table here, the store data. If I look at the store data, I've got 700 rows, but each row is one of 6 or 7 different products. And maybe I just want the unique product list in there. I want the unique product list. So what I'll say is I'll say equals unique. And I'm going to say, what do I want? I'm using a table. It could be a range. And I'm just typing the name of the table in. It's quicker than just going back, but I could have picked it up. And I'm just going to say unique store product. I'll close that. And what I get there is I get the list of products. Now, what I want you to notice is that I put a formula in cell B12, this yellow cell, but notice that the results are in B13, B14, all the way to B17. They've spilled down. So this is maybe a first time that some people are seeing this in Excel, that we've got these spill formulas, and they are very useful. Notice if I click on B13, not the first cell, if I look at the formula bar up here, I'll put it in red, you can see it's there. It's kind of grayed out, which means we can't change it, but it's spilling, the formula is spilling down there. So that's our spill formulas. Now, spill formulas are very useful. Let's first of all say, actually, let's say that we've got all this data, but really we haven't sorted it in alphabetical order. At the moment, it's sorted, and it's not at the moment. So I'm just going to say equals. I'm going to use sort and a function that I'm going to click on B12. And what I'm going to do now is going to click on hash. Notice what happened with hash is that it's created, it's not looking not at B12 any longer, but it's looking at the results that were spilled from the formula that is in B12. So I can just say sort B12 hash. And what it does, very simple formula, but now I've sorted all my products. Finally, I might want my products in not in a single column, but in a single row. So I can use another function that spills, transpose. and I can simply transpose D12. Again, I'm using the spill reference operator, and I get that. Lovely. So those are the formulas. And what we're seeing is it's our first introduction to spill formulas. So they're very useful. Let's just have a look at something else that we can do. Again, what I'm going to do is I'm going to copy this down. Say that we wanted them sorted, not alphabetically, but high to low. I just copy this, it's quicker. I'm going to come over here. I'm going to get my products again. And I'm going to come to my sum ifs. And I'm going to say equals. Sum ifs, if you haven't used it, is a much better version of sum if. It can take several ranges and it's organized. The arguments are organized better with the sum range at the top. So I'm going to say sum of my, again, I'm going to go to my store table and I'm going to sum my sales. And I'm going to sum where the criteria in this case is that my store, the product table, is going to be equal to Montana. I click on that. And there I've got my 50 million sales from Montana. But notice what I can do here. Rather than just saying B22, I can see B22 hash, and then it's going to use the spill results of that. So now I've got it spilled so that I've got the sales for all of them. So I've got the sales for all of them again. And this is where I've forgotten quite how I do it, but it's good to watch me. I can say I can sort all of that. I'm going to sort my array. I'll grab my array there. And I'm going to sort it by my index. Hopefully that's 1. That'll be probably my index 2. And it's probably -1. So if I wanted to sort it high to low, yeah. If I wanted sorted my products high to low, I can do it that way. Good. So that's an introduction to spill function. But what I want to show you is another spill function that is really useful called filter. And to do filter, I'm going to work out, get a range of all the days in the current month, and then I'm just going to filter out the Fridays. I just want the Fridays. So let's do that. To start off with, I've just created some cells here. I've got the current date. I'm using the today function. That's the 13th of Feb. I'm using the date function for the current day, the current month, and the first to give me the first day of the month. I'm using the EO month that gives me the last day of the month, and then I'm getting the day number. So it's 28 days in February. So I'm going to create another spill function that gives me the days in February. So I'm going to say equals. I'm going to say sequence. And sequence another spill function. I'm going to say how many rows do I want? Well, I want 28 rows because that's the number of days. I want 1 column in this particular case because I want them all the way down. I'm going to start off on the first day. And I'm going to say that it will go by 1 day at a time if I do. So what I get there is I get a list of all the days in February. And in March, I'll get 31 values, not 28. We won't bother about that yet. But what I might want to do here is I might want to say, first of all, let's just get the day of the week. So I'm going to use a function called text, and text takes a value. And if I say DDD, that will format it to give me a 3-letter day of the week. So today, the first was a Wednesday. Again, if I do B38 hash, I don't need to copy down. I can just get the numbers, the dates like that. So what I'm going to do here is I'm going to write a function. I'm going to say equals filter. And I'm going to filter my array. And that's my array of dates. And I'm going to say, give me back the rows where this particular condition. And the condition that I'm going to say is when this C38 hash, the day of the week equals Friday. And what I've got, especially if I come over here and I click on format painter, there we go. I have got the 4 Fridays in February. So again, we're taking a range or a table and we're filtering it. So very useful to come back and be able to filter like that. Let me just show you another example of filter, and it's this. A more realistic example. Again, I've got a tiny table here, but let's imagine instead of just being 12 rows, it's 12,000 rows. This table is actually called store summary. And maybe what I want to do is type in a region in here. I normally put in a data validation cell, but we won't do that for the moment. And I want the rows for selected regions. So let's just write in East here. I want my East rows. So I can say equals filter, and I can filter I'd call it my store summary table. And I'm going to filter the whole table, and I'm going to include it when the region, this one, equals, is it equals? It is equals, and then I'm just going to say G5, G4, that's there. Hopefully that's right. There we go. And so what I've got is I've got a sub-region here, a table which just shows my East. And if I wanted to look at my West, I could see my West as well. So filter is very useful. Just another example of filter, we can say where it's greater than 30,000. So I'll just say equals filter. And again, I'm going to filter my table. I can just click on come over here and choose the whole table store summary. And I can say I'm going to include when my profit is greater than whatever number I've got in here. And I'll do that. And that gives me all the rows where I've got sales of profits of more than 30,000. So filter, really useful. Right, so I've shown you some spill functions, but what I want to do is to talk about dynamic arrays, because you might think, okay, so Mark has just showed us some interesting new functions. That's good, but nothing fundamental going on here. Well, if you think that might be wrong. And what I want to do is to show you how Excel has changed. So let's imagine we have got a trivial thing here, but I've got a column here called first, I've got a column here called second, and what I want to do is I want to add the number in my first column to my second column. So if I come over here, the old way of doing it is saying equals A14 plus B14, and that's fine. And then of course I can just copy that down, and that's fine to do that. Another way I can do it is I can say equals, and rather than giving it a single value, I can give it a range, say A14 to A17, and I'm going to add another range to it. So what I've got here is got the same numbers, but instead of having to copy down a few rows or lots of columns, and I'm just able to just write the formula in one place and it copies down automatically. So that's called a kind of array formula. It takes an array as arguments and returns and it spills and gives an array back. So also, if we do a calculation, I've got a set of centigrade here and I want to find out what the kind of corresponding temperature in Fahrenheit is. So let's just write a formula. And if I were to do this, I'd say equals the centigrade number, whatever it is, multiplied by, it's 905, isn't it? 9 divided by 5, and then plus 32. And that gives me 0 degrees centigrade is 32 degrees Fahrenheit. And again, I can copy that down. Again, what we can do is if we have this, we can say equals, and what I'm going to do is I'm going to start off with that and give it an array, and this time multiplied by 9/5. That's a formula, and plus 32. And again, just one formula, it copies down again, which is useful. So we're writing much more, only one place, no chance for it, multiple copies to go wrong. Now, notice what I've got here. Here, what I did is I just put in standard values. But here, what I've got is I'm using my sequence function, which I've just talked about, to give me 6 values, starting at 0 and going in 20. So I get 0 through 100. And when I do that, I can come along and I can say equals, and then this time, A31, use my spilled operator, multiplied by 9/5 plus 32. And I get my numbers in there. And there's, for example, if this changes, let's say that we have only 4 steps for some reason, notice that this also changes as well. So we've got a formula that's adaptive to the number of values in our input, which is very useful. One of the challenges I talked about with the BMI was this. When I showed that BMI challenge, we've got this. Again, I've got a 2 by 2 matrix. And what I want to do is I want to say multiply these numbers. And again, when I do this, it's always really hard. I have to say equals, and I have to click on this one, and I want to fix the row. I want to fix row 40. So I want to say $40, and I hope I get this right, multiplied by, in this case, I've got to fix the column because it's the F column which has got those numbers in. So I have to say $F41. That seems to be right. And so what I have to do is copy that down, and then I can copy that over. And I hope that's right. Yes. But it's always a pain to get this mixed referencing right. One of the things we can do here is I can say, again, and I can just say equals. I'm going to take my rows, and I can just give that as an array multiplied by my columns. And there we go. Again, one formula, much easier to write, much less likely to go wrong, and so on. So I think that's a nicer way of doing it. Just to prove the point, I'm going to take a really old school function like len. And len is a function that takes the length of a string and just returns the number of characters in the string. So if I want to find the length of Luke Skywalker, I say equals len and then click on that. And again, I get 14, and again, I can copy down. This might be laboring the point a bit, but of course I can say equals length. And this time, if I just pass in this array, it will give me the lengths of all of those. So again, so what we've seen is that under the covers, if we have array formulas in as arguments, we get an array formula, a spill result out, which makes a lot of things easier. Okay, let's talk about that second challenge that we had, which was the splitting those Titanic passengers. Here I've got some, again, some names, and I want to split them up. Because these dynamic arrays underpin everything, Microsoft have been able to bring out some functions that use them and spill results. So, and there's been a bevy of functions recently, all to do with text. So what I'm going to say, if I want the first name, I'm going to say, actually, give me the text before, and I'm going to pass that argument in, and I'm going to say, what I want to do is I want to say, in this case, it's going to be, I'm going to put in a space. So that will give me the text before the space, and it should default to the first instance. So if I click on that, I get Luke. In this case, I've got to copy it down. So there we have the first name. What I can do is also get the last name with text after. And what I'm going to do, again, click on my friend Luke. And again, it's going to be the space in this particular case. And then I'm going to say, actually, just to make sure, because Beru, Whites and Laws has 2 spaces, I can just say, actually, after the first instance of that, number 1, and copy that down. So I'm going to get the last name, anything after the first name. If I want to split them all up so that Beru has their 3 names, I can say equals text split, and I can just split that here. And oops. Yep, would help if I said text split, and the column delimiter, again, we have to say, there we go. And there we go. And if I copy that down, we'll see, let's try that one again. Copy that one down. What did I do there? Yeah, copy down there. We see, because this person has got 3 names, it splits them up and copies into 3 positions. So again, a much nicer way of kind of splitting our text. I'd like to just let's have a look at, that's what I wanted to show there. Okay, let's go to our issue of stacking our columns. And what we have here is we have, make the zoom in a bit here. I'll do that. We've got some data, and here I've set it up in this example for January, February, and March. It could be if you've got kind of different divisions, it could be different divisions, but often we've got this data, and what we want to do is we want to stack it without going copy paste, copy paste. So one way we can do it is this. We can say equals. We can use a spill function called VSTACK. And VSTACK, what I can do is I can just give it the first array here, and I can stack it with another argument, as many arguments as like the second array, and I can stack it with the third array. And so when I want to do that, I can get my data there, and it's nicely stacked data. Obviously, what happens if I can come over here and if I change this to say the 17th, that will work. You see, no need to manually copy and paste. My problem with this particular bit comes when I want to add a new row. So maybe I want to put something in the 21st or the 3rd, and I'm going to say Charlie, and I'm going to give it 20. Now my problem is that that has not come here because it's only still stacking this range. So one way to sort this out, instead of having our data in ordinary tabular ranges, what we can do is we can define tables. So here what I can look, I've already come along and defined a table. So what I've got here is here is a table called January table. And I talked a lot about tables in the first one. What I'll just do is just show you how to do that. Here we've got a table again. It's called Feb table. And I've got a table as well called March table. Just a quick reminder, if you weren't here, when we've got our data in table, it's really useful because we can do lots of things. And again, I talk about that in the first session, which is actually on our YouTube channel. But for example, just to show what I'm doing, this data is in a tabular format, but it's not quite an Excel table. To create an Excel table, I come over here and I can just do Control-T or insert a table. It gives me, puts these kind of marching ants around the kind of area of a table. I'm going to click on this. And what I've done there is I've created a table called Table 13. I'll just call it Demo Table. I can rename it. There we go. And that's creating a table from the data. And the good things about table, let me just remind you, if I did 11th of the 2nd, delta, and 23, what you can see is that the data has it's interesting that the data has expanded. The table has expanded rows and it also columns. Now let's use tables here, and what we can do is we can say equals VSTACK. I'm going to stack them up, but this time I'm just going to choose my January table. If I just I can write it in or just hold it there. I'm going to choose my February table. I can write it in, and I can choose my March table. And I put them in. And there I get my data for it. And what I can do is add some data to this. If I want to say the 17th of the 3rd. And I just say echo and 20. You notice that we get the data there. We need to come along. It doesn't, unfortunately, do the format, so I've got to put my formats there. But as I expand my source data, this combined table will also reflect any changes that I make to my source data tables. So that was a problem that was actually very hard to do in Excel beforehand, but now we've got these functions like VSTACK, we can do them. And there are a lot of other functions as well. For example, I just show XStacks, perhaps not as useful, but what I can do is I can say equals, this is a horizontal stacking, and I can say equals HStack, and I'm going to stack these maybe, I'm going to stack these like this. If I stack starting with the that, and then I can stack. It doesn't make too much sense to stack these. I'm going to stack and then the demo table. Let's just do those two, and let's just do those two. I can stack things horizontally if I want to. It may or not, in this particular case, may not be particularly useful. VSTACK is more useful, but we can do those things. Okay. Right, so that's what I wanted to show you. And what I'm going to do now is go back and talk about those challenges that I started with. And what I'm going to do is minimize that. I'll come over to here and look at my challenges. So these challenges, I'll start off. I'm going to leave these challenges actually. I'll just do this one, but leave these other two for you to do later on. I'll just start with split text because this is something again, what I can say here is I can say equals. Now I can use the text before. In this case, I can say the text before. I click on that. And this one is it's going to be the text before the comma. And I can close that. And I can copy that down. And so, and again, here I can say, just to get the title out, I can say equals text. Actually, there's an even better way of doing it. What I can do is this. I can come over here and I can say equals. Don't need to do it the long, even that I can say text split. And I can say I'm going to split this data. I'll just split it first of all. And I'm going to split it first of all with the comma. And let me just copy that down. So I'm halfway there because I've split on the comma, which gives me my last name. And I want to now split on the comma and the full stop. So what I can do is I can say, actually, I can come over here and say, actually, what I want to do is I want a list of comma, and hopefully this works. Or is it the other way around? Let me try and remind it. I get my apologies. I want to come over here and I want to do a list. In my list is going to be a comma, and in my list is also going to be a full stop. Let me see. So I've used these as curly brackets to say there's a list. Let me just take off that. There. And I'm going to split that. And what happens there is I'm saying, I'd like you to split it on any of these, either the comma or the full stop, and that gives me a very nice way of splitting it into exactly the way that I want. Again, we're using one formula rather than 1, 2, 3, 4, and complicated formulas, and it didn't even finish that off. I'll give you, we talked about append data, so I'll leave that as if anybody wants to, they can try that out with the example file. And also when I talk about calculate BMI. So as a quick reminder, the formula approach is to come along. What we've got there, we've got the old-fashioned cell approach, but the formula approach is to equals, it's our weight divided by our height, and this has to be squared. That means to the power 2, and we can bring it in again. Just one formula rather than copy down and a simple formula. So there's some other ways to do it as well. You can try them out. If we've got build references here, just to make the point here, this is not. These were just numbers. 60, 70, 80. Those 6 numbers. If I've got build reference here from a sequence, and that from a sequence, it becomes even simpler. I say equals my weight hash divided by my height build reference squared. So what I hope you can see from that it's a lot simpler. Right, so that's where I'm going to stop.